So guys, in the previous video, we had filled up our tables and we realized one thing, that these two expressions, okay, 2x plus 3x and 5x are actually here. Do they produce different answers? No, they do not. And here, do they produce the same? Yes, we underlined the same. So what we were doing in that table, we were actually doing what we call in mathematics evaluating an expression. How were we evaluating that? Because we were given an x value. So where we saw x, we would put up a 3 and find the actual value of that expressions. Now, guys, here is the point. Where are we going with this? Why was I going through all that? Well, since we got the same values for those expressions, we call them equivalent expressions, okay? They are written differently. One is written as 2x plus 3x, another is written as 5x. But we realized that whether I said x was 3 or whether I said x was 10, we would get the very same answer. Okay, so we say they are equivalent because we got the same numerical answer. So that's one of the things that you guys need to be aware of, okay, that some expressions will be equivalent. In other words, some expressions in algebra might be written differently, but they may actually be one and the same thing. Now, we saw it with numbers. We're gonna learn how to realize that actually these expressions are the same. So here's another possible questions. Let's look at this. Say whether the following statements are true or false. Explain your answer in each case. The expressions 2x and plus 3x and 5x are equivalent. True, because we have just spoken about that. When you put x equals to 3 or x equals to 10, you get the same answer in both expressions. What about this one? Well, this one looks different. There's no x here. So let's test it a little bit. Let's test it with those same values. If I put x equals to 3 here and I add 3, this is going to give me 6 plus 3, right, which is a 9. But if I put a 3 here, I'm going to have 5 times 3, which is what? A 15, okay? As a matter of fact, let's just go back to our table and see what we are talking about. In other words, we want to check. This is what we are checking, guys. Come, stay with me now. We are checking if this expression is equal to that expression. We have already established that this one here, A, is equal to B. That was a good check. I want to check if A is equal to C. And we realized, actually, you will see we were getting different values here. Remember, in that table, go back to the video, guys, if you can't remember that, and we were getting different values. And so because we were getting different values, guys, then our answer here must be false. The expressions are not equivalent, okay? Now, let us go a little bit. Let us level up a little bit, okay? Check these expressions. You've got an expression here, 3x plus 2z plus y. Guys, remember, letters represent numbers. So these things are different numbers, 3 different numbers. And the expression 6xyz. Now, let me remind you, 6xyz is the same as 6 times x times y times z. Here it is written. So now let's find out, let's check. What is the value of 3x plus 2z plus y if x is 4 and y is 7 and z is 10? So let us evaluate that. This is 3 times, what is x? 4. Then I say plus 2. What is z? 10. Plus, what is y? 7. Now let's see, 3 times 4 is 12. 2 times 10 is 20 plus 7. Then I just group everything. This seems to me it is That's going to be a 32. Seems to me it's a 39. Okay. Of course, that's okay if you found it. If you didn't find it, it's okay to go to your calculator. Let us do this one here. This one is times. Okay. So let's do this one. The same values. So I'm going to have 6 times 4 times 7 times 10. So let's quickly press that in the calculator. 6 times 4 is 24 times 7 times 10. That gives us 1,680. All right. So you could have thought of this as 20. Yes. No. Yeah. 6 times 4 is 24. Times 70, something like that. So that's another way to look at it if you don't want to multiply everything out at the same time. So guys, are they equivalent? That's the question. The answer is no. Why? Because we don't get the same value, okay, when we substitute. Okay, I spoke about substituting. So when we have after evaluation, we don't get the same value. 1,680 is way bigger than 39. So these expressions are not equivalent. Okay, I hope you guys understand this concept very well now of what it means when we say expressions are equivalent. Okay, now I want us to go into another interesting concept here. Okay, we're going to move into another interesting concept of now what we call like terms and unlike terms. So let's go back to that nice expressions that was equivalent. Here it is, 2x and 5x, okay? We know already that these two are equivalent. So what that really means is that 2x plus 3x is 5x. That's what it means for y, because we got the same value. I mean, the same value we got here was equal to that same value. Now, we need an explanation for this. How does that happen? Well, 2x is plus 3x is actually 5x. Oh, wow, that's a great discovery, isn't it? So guys, what happened actually, if you think about this, I had 2x's and 3x's. Now, does this make sense? They give me 5x. Yeah, it makes sense. If I take an x and I add an x, I get 2x. If I take an x and an x and x and I add all them up together, I get 3x. Remember, we said x represents a number. So let's think about it. If I have 2 plus 2 plus 2 plus 2 plus 2, what is 2 plus 2? 4. What is 2 plus 2 plus 2? 6. Isn't it? Okay, maybe 2 is a bad example. Let's look at 3. What if I have 3 plus 3 plus 3 plus 3 plus 3? Let us see. This is going to be a 6. That's going to be a 9. These things are going to add up and give me a 15. Do you see that? So whatever number it is, as long as I add it twice by itself and I add it 3 times by itself, instead of doing this long process, I can simply write that as 5x. Okay, now because we have this result, which I hope you guys understand, in mathematics or in algebraic language, we say that the expression 2x plus 3x simplifies to 5x. Yes, guys, you will see those questions where they say simplify. So what they mean really when they say simplify, they're saying take this expression and write it in another way, okay? A way which is actually much simple. If you think about it, the word simplify comes from the word simple. So you will get this scary looking expression and they want you to write it in simple terms. I am sure you agree with me right now that actually 5x looks much simple, okay, than 2x plus 3x. And it is really simple in a sense that when I do 5x, I do a little work. When I do 2x plus 3, I do a lot of work. I'm sure you have seen that when we're substituting, I had to say, for example, when x was 3, I had to say 2 times 3 plus 3 times 3. Then I had to write another step and say this is what, 6 plus 9. Then I had to say what, this is 15. Whereas in the simple version, I just had 5 times x, then I just said this is 5 times 3, and I arrived at my answer. You see, this is simple. I just had 2 steps. This is not that simple. I had 3 steps. So that's what simplifies means. Says, take this expression, write it in a very simple way that will not require you to do a lot of work when you evaluate the expression. So guys, I want you to try this. I'm going to leave you with this. Please try this. In the next video, we will start by looking at the solutions. I want you to simplify, okay? Simplify. The question here is simplify. Or in other words, write down this expression, okay, as equivalent. In each case below, write down an expression equivalent to the one given. So what is an expression that is equivalent to this one? Use the same concept that we used here, okay? I want to see what you guys will get. Okay, I'll catch you later.